We're recording. So we went through Git. It allows you to track the code. Um, what the containers do, it allows you to control the environment. So whenever you run your application, it often relies on different libraries. Okay, and unless you're building everything by hand, you're gonna need quite a bit of libraries. And then what containers do for you is it allows you to manage everything outside of your application. So this is kind of referred to the environment. The environment where the application runs in. That's what the container will help you manage. Oops. So what it looks like to all right. So what it looks like in actuality is you have your host. So this is your, we call it the host. And this is your Mac, Windows, some flavor of Linux. And then when you run your container, this is actually the container. So let me outline it in blue instead. So the blue box is actually your container. And within your container, you're going to have the code to your application. And you have the instructions to kind of how to install how the container installs the library so that your application can run properly. So to drive it home with an analogy, if we think about life, you only have control over yourself, and we'll call you the application. And the environment you're in, so let's make this blue as well. So the environment you're in kind of affects you, the application. So the environment includes weather, whether it's raining, all the people around you, if there's wind. So all those things in your environment will affect you, the application. So that's kind of a weird little analogy. So in life, you can't really control the environment, and it's probably better that you don't, because otherwise it might be a very boring life where you can just it's only as cool as your imagination can be. It leaves no chance for spontaneity or just random things that might make you happy. However, in the software world, you want to control everything. You want to know what's in the environment. If there's a version, one that worked, but when you updated to version 2, it broke. You want to kind of have that insight. And containers, through the use of source control, will allow for that. So is there any questions, comments, or concerns about that kind of like a brief overview of containers? Okay, so another term they like to use a lot is called virtualization. Um, because virtualization uh, back in the day, you had your physical box, and then they later made VMs, virtual machines. So one physical box can actually run multiple kind of like OSs. So then containers is actually kind of like the next generation of virtualization. So now you can have one, physical box, with RAM, hard drive, CPU, and I probably should use a different color. So we'll call the VMs green. So you can have, now with virtualization, with VMs, you can run multiple OSs on the same box. And now container came along and said, well, within your multiple OS, you can actually run multiple containers. And containers can share resources within the VM, the host, similar to how the VMs share the hardware on the box, the physical box. So, maybe the the part that's filled in is maybe the part that of the OS that's shared. Oh crap!
Are you showing something on the screen?
Yeah, sorry. Um, it's actually on the next slide. Sorry about
Oh,
that.
okay.
Let's see. So this so thank you for catching that. So the first generation, multiple machines, but carrying around hardware was tedious. Buying hard drives, dealing with hard drive, failures, was just kind of error prone, and so that's why VMs were made. So VMs then allowed you to have one machine but multiple OSs, multiple virtual machines. So all the VMs would then share the same um, hardware. So the CPU, uh, I'm just going to draw it like pretend the filled-in part is like the CPU, RAM, all the hardware. So all the OSs, all the VMs share the same hardware. So the next iteration, we have containers. And so each container now runs within the VM. And what it then shares is all the common libraries within the OS. Okay. So that's a kind of brief overview of virtualization. Going just a edge case here. You don't need VMs like what we're doing now today. You're gonna have your development machine, and this is your Mac, Windows, or Linux. And we are just going to put containers straight into your development machine. So if we were to kind of like map it to what we had at first, your physical box is in essence your VM, and all your OS shared stuff will be shared amongst the containers. All right, so if that's all good, we're going to dive into the demonstration. All right, so I'll stop the video here.